Hello, and welcome to this video that is going to talk a little bit more extensively about the six trig functions. You should have some basic knowledge about how to compute the six trig functions when given a point that lies somewhere in the xy plane, and theta is created by making an angle in standard position whose terminal side intersects that point. We're going to extend that question now a little bit more. It's kind of almost a work backwards type of question where we're going to give you one of the values of one of the trig functions for that particular angle theta and say find the other five. So you should have some knowledge of how the six basic trig functions work, which are written here. And you also have to have some knowledge of what we have discussed in class, or you've discussed with your teacher, the sign of the trig functions in particular quadrants. You probably know the device of all students take calculus for determining what is positive in which quadrant. You have to be able to apply this logically as we do these problems. So I will get into some examples quickly here, and we'll take a look and see how they're done. Okay, so directions. Consider the given value while theta's terminal side is in the given quadrant. Find the value of the other five trig functions for theta. Make a sketch as well. So here it says that the cosine of theta equals 3/5, and it's in quadrant 4. Okay, so what I'm going to do is sketch the terminal side of the angle being in quadrant 4. Okay, again, the angle you're dealing with in standard position is this one. Okay, and if it's in quadrant 4, you should note very quickly that this is the C quadrant. Okay, of all students take calculus. It makes sense that cosine is positive here. The value they gave us is positive. Okay, but you should also notice when you're making this XYR chart, which is an essential organizer when doing these problems, a couple of things. One, in the fourth quadrant, X is always positive, Y is always negative, and R, being that it's the radius of a circle, is in fact always positive. Okay? So, again, you'll be able to always find the six trig values if you have an XYR chart, because if you notice, six trig values are just based on ratios using X, Y, and R. Okay? So, from here, I have to examine what cosine of theta is, and it's equal to X over R, so I should be able to determine that the X is 3 and the R is 5, and I'll put that into my chart. X is 3, R is 5. Okay, now I need to find Y, so I'm going to do that with the formula for R. Okay, if you remember, it's R equals the square root of X squared plus Y squared. So we have that 5 equals the square root of 3 squared plus Y squared. Okay, and we have that 5 equals the square root of 9 plus Y squared. And now I will square both sides. Continue up here. 25 equals 9 plus Y squared. Subtracting, I get 16 equals Y squared. Then I get Y is equal to plus or minus 4 when I solve that equation. But you've already established that although Y is plus or minus 4, in the fourth quadrant, Y has to be negative. Therefore, we know that Y equals negative 4. Okay? Now the rest of this gets academic pretty quickly. I was given the cosine value. Cosine value is 3/5. And quite easily, the secant value is just the reciprocal of that. So they gave me one value, and it's a little knowledge of this, the reciprocal, and it's kind of pretty easy to do, knowing that the secant will be 5/3. Okay, and then I continue to go on and say sine of theta, which I look here as Y over R, and I can look at my chart and see that it's negative 4/5. Nothing to simplify there. tangent of theta, looking at my chart, is y over x. Looking up here, we see that it is negative 4/3. Nothing to simplify there. Cosecant of theta, I could look at it as being the reciprocal of sine, or do r over y, which is 5 over negative 4, same as negative 5/4. Okay. And the cotangent of theta will be the reciprocal of tangent. Or I can look at my chart for the rule. Both are acceptable. I get negative 3/4. So again, I was given this value to start and found the other 5. Knowing the quadrant is so important. Okay? Just to reiterate that, there are 2 places that cosine is positive. It's in the first quadrant and the fourth quadrant. Well, if I didn't consider this angle to be in the fourth quadrant, my signs down here and my answers would be different than they are. They would all be positive. So you have to apply the idea of all students take calculus to determine the appropriate signs in your XYR chart when you then apply them to the rules. Okay? So this was a decently easy example because I didn't have to simplify any of the fractions, and I really didn't have any roots to deal with. I had all integers, okay, which is nice. You probably could have looked at this example very quickly without doing any of the solving for r. You could have just said, wow, if x is 3 and r is 5, it's going to be a 3, 4, 5 triangle. Again, you'd still have to establish that y is negative, but it's still a 3, 4, 5 triangle. Okay, let's take a look at the next example. It's a little more difficult. Okay, so again, if we have that, consider the value, the given value, while theta's terminal side is in the given quadrant, and find the value of the other 5 trig functions. So it says the sine of theta equals negative 1/2, and we're in quadrant 3. So the standard position angle is down here in quadrant 3. Okay, so this is the angle we're dealing with, called theta. Ironically, in these problems, you're not even finding theta, okay? You're just finding the values of the trig functions in relation to each other. Okay, so in quadrant 3, when I go to make my XYR chart, I'll take into account this is all students take. It's tangent that's positive here, okay? And I'll note in quadrant 3 that for x, y, and r, x is negative, y is negative, r is always positive. I'll continue to make this chart in a second. I will examine the sine function here that's given to me, and we know that sine is equal to y over r. And if it's a negative number, it has to be the y that's negative, because the r can't be, because r is always positive. It also makes sense that y is negative, because we're in quadrant 3. So I've got a negative 1 here for y, a 2 for r, and I'll find x with the formula. Okay? You might be able to take a shortcut here. If you've seen it, I won't. I'll just try to reiterate how to use this formula. So we've got the square root of x squared plus y squared is equal to r. Okay? So I've got 2 equals the square root of x squared plus negative 1 squared. So that's going to give me 2 is equal to the square root of x squared plus 1. Now I'll square both sides to get rid of the root and get 4 equals x squared plus 1. 3 equals x squared, and x equals plus or minus the square root of 3. But again, I've already established that because we're in quadrant 3, the value of x is negative. Now I get the opposite of the square root of 3. So cosine of theta is equal to x over r, as I see here. So I just look at my chart and I say it's the opposite of the square root of 3 over 2. Sine of theta was given to me as negative 1/2, so I'll just recopy it. And the cotangent of theta is equal to y over x. Excuse me. Oh, big mistake there. Try and stay in order. You can do them in any order you want technically, but it's very easy on your teacher's eyes to be able to write these tables out in a familiar way that they're expecting, and I expect to see cosine, sine, tangent. Okay, so we have tangent is y over x, so I'm going to get negative 1 over negative root 3, which is equal to 1 over root 3. But then the only issue with that is I have to rationalize the denominator, multiply both numerator and denominator by root 3. Don't forget I've just multiplied by 1, so I haven't really changed the value of anything, which gives me root 3 over 3. Noting it's positive makes sense because, again, the angle is in the t quadrant if all students take calculus. So I should expect a positive there. Now I'll do the secant theta, which is r over x, which is equal to 2 over negative root 3. Again, to rationalize that, I'll multiply by root 3 over root 3, giving me negative 2 root 3 over 3. Cosecant theta, quite easy here being the reciprocal of sine, getting negative 2. And now the cotangent, to clean this up, being x over y, is the opposite of root 3 over negative 1, which is in fact root 3. So again, I was given one value of a trig function for some given theta, which again we haven't found. These values should look decently familiar here to you, and you should be able to know what the value of theta is just from the chart, the special angles chart. Okay? But using the given value and the information about the given quadrant allows us to build this very handy XYR chart, reference it off the 6 trig functions, and answer this question to give the other 5. Little trick here with needing to rationalize the denominators. Also, if you ever had to simplify fractions, you would need to do that as well. So I hope this has been informative. You're putting together a variety of skills here that are all very important. Feel free to practice and watch again.